What I'm going to do now is just quickly go through the design of the sCarpet function. Let's see, we consume a number, we produce an image. Now let's see. We start with the base case, or because it's a generative recursion function, perhaps I should say the trivial case, which is that we're making a very small carpet. I'll just use the same cutoff constant as before. Maybe I could have done a different one, but I'll just use the same one. If we've reached that size, then the result is just a square of that size. That's an outline and red. I could also perhaps have made a constant for the color. I didn't do that. Now let's do one that's a bit bigger. Now it doesn't have to be times cutoff 3. I'm just making it times cutoff 3 to keep the math simple. Because of course each of the inner squares is 1/3 the side length of the outer square. So that keeps it a bit simpler for me. If I'm doing that carpet, then let's see, it's an overlay. It's an overlay of a square of that full size. With what? With, well, I need some inner squares, and I'm going to need the same square repeated times. So I'll do that local thing again. I'll call the one that's actually a carpet, I'll call that one sub. And what is that one going to be in this case? Well, it's going to be a carpet of size cutoff, because times cutoff 3 divided by 3 is cutoff. So that's a square of size cutoff, outline, and red. Remember, we're doing the case that's just one bigger. There's just going to be one recursion here. And we also need that blank one in the middle. That's just doesn't have any color to it. That's just a square of size cutoff, but it's, I guess it doesn't have to be solid. The key thing is it has to be white. So now I've got those two. I've got the outer square. I've got the makings of the 9 inner squares. Now I just have to put the 9 inner squares together. Above, beside, sub, 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 beside, sub, blank, sub. Now you see why I used a 3-letter name for blank, right? There's a method to my madness. Beside, blank, blank, blank. That's all of that. Run it to see if it's well formed. It is. I can't really see it. Let's do that same trick I did before of temporarily making cutoff much bigger. Running it again, looking at my failing tests, but seeing if the expected values look, that doesn't look very good at all. What happened there? That's not what I wanted. Oh, I put nothing but blank on the bottom row. Silly me. The bottom row has to be sub, sub, sub. Let's see what they look like now. Oh yeah, that looks much better. It's not the full carpet because it's just one level of recursion, but it's a good start. Okay, now I go get the template for generative recursion. There it is. I copy it. I bring it over here. I paste it in. I comment out the stub. I rename the template function. I rename the recursive call. And I like the parameter S for this because it's the side length, so I got to fix all of those. And now I've got to decide some of these other things. Let's see, what is the trivial case? What's the case where there's no more recursion? Or in our old terminology, what's the base case? Well, that's the same as it was for the triangle. It's just less than or equal to S to the cutoff. What's the trivial answer? Well, the trivial answer is we just make a square of this size. And what's the non-trivial answer? Well, we're going to overlay a square of this size with what? Well, we're going to do this local thing so that we don't make the recursive call 8 times. There's the recursive call from the template, but we have to decide what next problem is. Well, next problem is S divided by 3, because each inner square is 1/3 the side length. We also need blank. And it's above, let me try to get it right this time, beside, sub, 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 beside, sub, blank, sub, beside, sub, sub, sub. Run that, test pass, and let's try a big one. That doesn't look quite right. Why doesn't it look that right? It doesn't look rich enough. Oh, I know what's wrong. Forgot to change cutoff back to 2. So there's not many levels of recursion. Let's try it again. This is taking longer. Yeah, that looks a lot better. So there you go. That's my version of the Sierpinski triangle and the Sierpinski carpet. If your version of the carpet came up significantly different than that, or even different, be sure to compare my version to your version and be sure that your version really only differs in details. Your version really still has to have this same recursive structure based on this template. And then in the next video, we'll talk about the last piece of the recipe for generative recursion.